So to solve this conundrum, what we are going to do is that we are going to create a new variable, or rather two. We are going to create a private int num deleted, which will keep track of the number of things we delete. This will be useful in a moment. And then we're going to do a private static final entry. And because it's static, we don't use any generics right over here because it would be really weird otherwise. Entry, and we're going to call it deleted, equal to a new entry null. And this is why I've prohibited using null as a key in this, and that's because we're going to use it ourselves in this final entry over here. Can I do null over here? No, I cannot. So private static final entry deleted. Okay, and this deleted will stand in place of anything we delete. So what we're going to do over here is that when we delete something, what we're going to do is that we are going to say deleted. We're going to set it equal to deleted. And what's great about this, by the way, is that because it's static, we'll only ever use one of them. Oh, actually, we don't need a static. So public private final entry deleted. Yeah, let's just get rid of the warning. KV. Identifier type expected. Can I just not do that? Oh. Right. Silly me. So there. Be that. Yep. Because it's going to be an instance variable here, right? That's perfectly fine. Just want to do to remove warnings that way. And so now we set that equal to deleted. Set the size minus to minus, and num deleted plus plus. And now, basically, we've marked this square as deleted. Okay? And by doing so, we're basically going to mark that square as completely unusable until our next iteration. And that there was something there, so you should probably skip over it if you see it. So for instance, if the index is equal to null, but otherwise in all respects we're going to treat it like a null. So watch. If table is equal to null, or table index equals deleted, then what we're going to do in this case is that we're just going to return null, like we normally, right? We deleted, if we find a null, if we're going through this, iterating through it, looking for the key to remove, we find a null, or we find this over here that we've hit a spot that's been deleted. Let's see. If we hit a spot that's been deleted, well then, we've gotten to the end of the road. Oh, let's see, actually. Let's see. Let's just double check. Right, my logic over here. Get, find, if it's equal to null. Yeah, okay, never mind. There we go. Yeah, just null. Forget what I said over there. So the only real place this is going to impact us is over here. So we'll delete something. If it's null, great. So over here, yeah. So when we add something, if we've deleted it, so over here, again, if it's an empty spot, we're going to just, yeah. So the way this works is that basically by setting this equal to deleted, we kind of let the program know that basically there was something there, and so if you want to seek for this, like we had previously, right, for yellow 8, this is going to work right now, because now this will say, oh, look, null comma null. Interesting. Or null key null for the deleted thing. But now it will skip. Now when it's looking over it, it says, ah, there's a deleted entry here, so that means there might be stuff behind it. That's what's going on there, right? Because it's been deleted here. Okay, similar. So that's how that will work. And now over here, when we rehash things, if it's deleted, what we'll do is that basically we'll say, well, first we'll go over to here. And first now we have to change our rehashing, because this is still taking up space in our hash table. It's okay to waste space though. So if 1.0 time size plus num deleted divided by capacity, right? Because those num deleted still take up space. That's greater than equal to max load rehash. And what we're going to do to make sure that we don't continually waste space, is that we'll say num deleted or old table over here in the rehashing, old table I equal deleted. So if that's the deleted node, we're just going to skip over it and not add it back in, because that would be silly. Set num deleted equal to 0 over here. All right. So to recap, because I'm sure that was confusing, we need to have a deleted node to mark that we need something to mark that this space has been deleted, right? And I'm not going to go through and make our code easier, rewrite our code to deal with the fact, okay, can I replace this? That might lead me into more edge cases. So I'm just going to mark it as deleted and say that's eventually going to be replaced. Okay. So I'll decrease the size, but I'll increase this number of deleted, which I'm keeping track. And over here, I'll decide to rehash based on adding the size plus the number of dead spaces now, because num deleted is the number of dead spaces. When I delete something, it essentially is becoming a dead space, just simply for the ease of analysis. And then when I rehash, if I hit a dead space, I just skip over it rather than trying to add that dead space back in. And this allows me to retrieve something, because now there's something there rather than null, because null means nothing was ever here. This means something was here. You might want to look behind it if you're looking for something. Okay, so now finally let's get this toString working.